Hi, this is Keith Townsend, and you're watching episode 42 of Virtualized Geeks Tech Talk. We're going to try and tackle a really tough topic, software-defined storage. There's a lot of confusion about what software-defined storage, how is that different from regular SAN management software. Every storage array has software, so by definition, isn't that software-defined storage? So let's move away from kind of the marketing term of software-defined storage and tackle it from practically a set of capabilities you're trying to achieve. And then we can tie that back into why we call it software-defined, or what I'd like to call abstracted storage. I think software-defined is a good definition for what it is you're practically trying to achieve. So just like everything that we call software-defined, we're trying to abstract one thing from another. In the data center, we call it the software-defined data center because we're abstracting the control of the data center away from the individual components into one centralized unit, such as storage, compute, and network, into OpenStack to manage your entire infrastructure. The same thing with software-defined networking. In software-defined networking, we're not necessarily trying to just virtualize the network or even virtualize the network at all. We're trying to control the network via software. The underlying network, again, can be a subset of a bunch of different components from a bunch of different vendors, but we give an abstracted view of that to some type of system for centralized management. There's no difference when it comes to software-defined storage. So I think one of the complex things when it comes to software-defined storage is that we get software-defined compute. You virtualize a bunch of x86 hardware, you put a wrapper such as vCenter, SCCM around that, and then you're able to manage your compute in a way that you haven't been able before. Very mature software-defined subsystem. Networking, we're starting to understand that a bit. We look at NXX. Took us a while to kind of understand what virtualized networking is, but we could take the concept of a router and virtualizing the router. We could take the concept of a switch and virtualizing a switch, and then adding control around that to make it software defined. So NXX provides that software control around it, or Open Daylight, or OpenFlow, or whatever you want to use to decouple the control plane from the physical device. So we get those things. But storage is really tough to think of in a virtual sense. You have disk, you have software that manages the disk. Decoupling those two kind of doesn't make sense. You know, we have a storage array. How can you manage a storage array and take away the software that manages the storage array and put that somewhere else? That doesn't make sense. Even when you take a look at Nutanix, when you take a look at vSAN, the software is tightly coupled with the storage at some point. So virtualizing the storage really doesn't make a whole lot of sense. We'd have to look at an example such as Amazon's various storage products that take a bunch of storage and kind of hides the back end of what's the underlying components of that storage to really understand software-defined storage. So Amazon's AWS is a perfect example of software-defined storage in general. It's the abstraction of the control plane, not the virtualization of the data plane. So, you know, when we look at a VMware vSwitch, that's a virtualization of the data plane. When we look at Amazon AWS storage, that's a virtualization and an abstraction of both the data plane and the control plane. We don't know if Amazon, and we know they don't, but we don't know if Amazon uses EMC storage, Hitachi storage, a bunch of white box storage to provide the actual data plane to us. All we know is that there's a bunch of pool storage. We contract AWS to provide an amount of storage and the class of storage. They abstract that storage from us, and they abstract the control of that storage from us. So let's bring that back to the enterprise. And what does it mean for the enterprise? The abstraction of the control plane. For service providers, software-defined looks different than it does for the enterprise. For the enterprise, we have different drivers. Our drivers are, we have a bunch of different storage arrays from multiple vendors. We need to put an overlay, the software-defined, on top of those multiple storage systems in order to provide an interface to either applications or orchestration tools in order to manage and provision the underlying storage. That, in a nutshell, is software-defined. I don't need to change my EMC array. I don't need to add software to it. I don't need to take my Hitachi array, bolt on some EMC add-on appliance to virtualize that control plane. I can take a solution such as OpenStack or VCAG and enable that software layer to abstract the underlying control plane from my clients. I'm not, again, virtualizing the data plane. What I'm doing is saying, from a practical sense, I'm putting an overlay on top of my control software that says, if client A needs storage from A, B, or C, that client doesn't know or care where it's getting storage from. My control software, and a great example is EMC's Viper does this. It takes that request and says to storage array A, which may be a NetApp NetFiler, and says provision, and this is the Nirvana, provision a 3 terabyte lung from this type of storage and zone it to this host. So the communication from the overlay doesn't take over the communication of the data plane. It just directs traffic, similar to OpenFlow. OpenFlow doesn't take over the communication of the or virtualizes the communication from host A to host B. It just controls the flow of the data and tells host A how to get to host B. Same thing with software-defined storage. So that's our definition, or specifically my definition of software-defined storage. Is my view of what software-defined storage practically adds to the enterprise. If you have questions, comments, or if I'm wrong, you know what? It's my video. We'll talk to you next episode of Virtualized Geeks Tech Talk. Thanks for tuning in.